Welcome to Module 1 on the Basic Data Analysis course. We'll be looking into Introduction to Data Analytics and Power BI. Under the following units, what is data analytics? Overview of Power BI and its components, and installing and setting up Power BI. This foundational module introduces the core concepts of data analytics and provides an overview of Microsoft Power BI, setting the stage for practical application in subsequent modules. Learning objectives. At the end of Module 1, learners should be able to describe the concept of data analytics, identify its purposes, and enumerate the types of data analytics. Define what Power BI is, identify the purpose of Power BI, and outline the key components of Power BI. Identify the two primary ways of Power BI installation methods and the step-by-step. What is data analytics? Core concepts and purposes. Data analytics is the practice of examining raw data to uncover patterns, trends, insights, and conclusions. It is fundamentally about transforming potentially large and complex data sets from incomprehensible numbers into coherent, intelligible information. Data on its own doesn't inherently provide value. It is the process of analysis that converts raw data into useful information and knowledge. This transformation enables organizations to optimize operations, understand customer behavior, and gain a competitive advantage. Types of data analytics. Data analytics can be broadly categorized into 4 types, often represented in a progression in complexity and value. Firstly, descriptive analytics focuses on summarizing past data to understand what happened. Techniques include data aggregation and mining to identify trends and patterns. Examples include monthly sales reports or website traffic summaries. Secondly, diagnostic analytics aims to understand why something happened by drilling down into the data to find root causes and identify anomalies. It often follows descriptive analysis to explore the reason behind observed trends. Thirdly, predictive analytics. It uses historical data, statistical algorithms, and machine learning techniques to forecast what might happen in future. This helps businesses anticipate trends like sales forecasts or customer behavior. Fourthly, prescriptive analytics goes a step further by suggesting what action should be taken to achieve desired outcomes or mitigate risk based on predictive insights. It often involves more complex modeling to recommend optimal strategies. The overview of Power BI. Microsoft Power BI is a powerful business intelligence tool. It functions as a collection of software services, applications, and connectors designed to work together seamlessly. Purposes of Power BI. Its core purpose is to take unrelated data from various sources, ranging from simple Excel spreadsheets to complex cloud on-premises databases, and transform it into coherent, visually immersive, and interactive insight. Secondly, Power BI allows users to easily connect to their data, clean and model it, visualize important patterns, discover patterns, and then effectively share these insights with others within or outside their organization. Thirdly, by facilitating collaboration processes, Power BI helps to drive a data culture where decisions are based on evidence derived from data. Fourthly, It empowers a wide range of users, not just dedicated analysts, to create compelling reports and gain valuable insights from their data. Fifthly, Power BI effectively acts as a bridge connecting raw data sources to actionable business intelligence delivered through a detailed report and dashboards. Key components of Power BI. Power BI is not a single application, but an ecosystem comprising several elements designed to work together. The three fundamental components are: number one, Power BI Desktop. This is a free application installed on a Windows computer. It serves as the primary authoring tool where users connect to various data sources, perform data transformation and cleaning using the integrated Power Query data, build data models, which is defining relationships and creating calculations with data, and design interactive reports with a wide array of visualizations. Most business intelligence projects and report creation tasks begin in Power BI Desktop. Secondly, Power BI Services. This is the cloud-based software as a service platform accessible via a web browser at app.powerbi.com. Its main functions are publishing, sharing, and collaboration. Reports created in Power BI Desktop are published to the services where users can view, interact with, and share them. The service is also where dashboards, single-page canvases, highlighted key visuals from reports are created and viewed. It provides features for schedule, data refreshes, security management, and distributing content through workspaces and apps. It is the primary environment for consuming business intelligence content. Thirdly, Power BI mobile apps. These are native applications available for Windows, iOS, and Android devices. They allow users to securely access and interact with your Power BI report dashboards while on the go. These include viewing reports, exploring dashboards, asking questions about data, and even offline access to previously viewed data. These three core components from an integrated suite catering to the entire Power BI workflow from creation, that is desktop, to sharing and collaboration, that is services, to mobile consumption, that is mobile apps. Understanding the distinct role of each component is fundamental to using Power BI effectively. Installing and setting up Power BI Desktop. Getting started with Power BI Desktop involves a straightforward installation process. System requirements. Before installing, ensure your computer meets the minimum requirements. Power BI Desktop runs only on Windows operating system, Windows 10 or later, or Windows Server 2016 or later. It requires at least 2 GB of RAM, although 4 GB is recommended, and a compatible NET framework, version 4.7.2 or later. Installation method. There are two primary ways to install Power BI Desktop. Firstly, Microsoft Store. This is generally the recommended approach. Installing from the store ensure you receive automatic update in the background. Download sizes for update are smaller, and administrator privileges are typically not required for installation. Direct download executable. You can download the installation file .exe directly from the Microsoft Power BI Desktop website. This method requires lower updates and administrator right to install. It might be preferred for specific version control or automatic deployment using command line options. Step-by-step installation using Microsoft Store. Open Microsoft Store application on your Windows computer. Secondly, in the Store search bar, type Power BI Desktop and press Enter. Thirdly, locate the official Power BI Desktop application on the search result and select it. Fourthly, click Install or Get button. Fifthly, the application will download and install automatically. Follow any on-screen prompts. Sixth, once installed, you can launch Power BI Desktop from the Windows Start menu or by clicking its taskbar icon. Initial launch. The first time you start Power BI Desktop, you may see a welcome screen offering options like getting data or opening recent reports. You can close this screen to access the main interface. Notice the icon along the left side representing the three main views: report, data, and model. You will primarily work in these views as you build your report. The ease of installation, particularly through Microsoft Store, significantly lowers the barrier for beginners to start using it. Now we've come to the end of Module 1 Course and Basic of Data Analytics using Power BI, where we considered Introduction to Data Analytics in Power BI with the following units. What is data analytics? Overview of Power BI and its components, and installing and setting up Power BI. In the next module, we'll be looking at connecting to data sources. Thank you. All right. Welcome to Basics of Data Analysis using Power BI, the aspect of installing and setting up your Power BI Desktop. Getting started with Power BI Desktop involves a straightforward installation process, which starts firstly with your system requirements. Before installing, ensure your computer meets the minimum requirement to install this package. Power BI Desktop runs only on Windows operating system, Windows 10, or later version of Windows. For Windows Server 2016 or later version, it requires at least 2 GB RAM, but 4 GB RAM is highly recommended. And a compatible NET framework version 4.7.2 or later version is recommended. All right, there are two methods of installations that was mentioned. We're going to be focusing on the installation through the Microsoft Store. So let me go to the Microsoft Store here. All right, the Microsoft Store is right here. If you usually goes easy to locate. So the Microsoft Store is generally the recommended approach. It's starting from the store ensures you receive automatic update, background, download sizes for update are smaller, and administrative privileges are typically not required for installations. So you start by searching Power BI Desktop. Power BI Desktop. Or type in Power BI, we're going to see Power BI Desktop. Click on that. Okay. Then you see where you click on Get button. It prepares the download. So it downloads automatically. That's getting files ready. So it will take a little more time. All right, getting files ready. It was so you can see or the interface is now been highlighted. Screenshots using the desktop, mobile app, other interfaces that shows visualizations and other things that you can do with the Microsoft Power BI. Right. So still they're still preparing the download, getting our files ready. Okay, our installation is done. So we click open. Okay. Take open here. See, there's a Microsoft Power BI. To log in. Now, first time to start Microsoft Power BI, you may see a welcome screen like this, offering you options like getting data or opening risk reports. You can close this search screen to access the main interface. All right, so this is the interface of your Power BI, and you could sign in if you have a Microsoft account to your account, entering your email and other things. And this is the brief way to actually install your Microsoft Power BI desktop. You primarily work in this view as you build your reports. The ease of installation, particularly through Microsoft Store, significantly lowers the barrier for beginners to start using the tool. Now we've come to the end of the module one of this aspect of installing for Microsoft Power BI desktop. Thank you very much.
Thanks for watching. If you found this video helpful and you're passionate about learning, don't forget to hit that subscribe button. We share practical tips, deep dives, and step-by-step guides to help you grow your knowledge and skills. You can also visit our website through the link below to access engaging courses. So if you're ready to keep learning and stay ahead, subscribe now and turn on the bell so you never miss a new video. See you in the next one.
Welcome to the Module 2 of Basic of Data Analytics using Power BI. In this module, we'll be looking at connecting to data sources under the following units: importing data for Excel, databases, and cloud sources, understanding data types in Power BI, and data loading and refresher. Connecting to common classes, step-by-step examples. While the general process is consistent, connecting to specific sources types involve unique details. Here are step-by-step guides for common beginners scenarios. Connecting to local Excel files. In Power BI Desktop, click Get Data on the Home icon, then select Excel Workbook. Browse your computer, locate the desired Excel file. Select it and click Open. The Navigator window opens, displaying the sheet and any defined Excel table within the workbook. Select the check boxes next to the sheets or tables you want to import. For best practice, formatting your data as an official Excel table. Click Insert Table forehand, which makes it easier to work with in Power BI. Fourthly, click Load to import directly or transform data. To open Power Query Editor first. Power BI can also import existing Power Query queries and Power Pivot data models embedded within the Excel file. Connecting to SQL Server database. Import mode. Firstly, click Get Data. Then go to SQL Server. Click on SQL Server. In the dialog box, enter the server name. For example, your server name or your server name, instance name, whichever one you saved it as. Optionally, enter the database name if you know it. Ensure the data connectivity mode is set to import. Then click OK. If connecting for the first time, you'll be prompted for credentials. Choose the appropriate authentication method. Windows authentication uses your current Windows login. Database requires a specific SQL Server username and password, and enter credentials if needed. Click Connect. You might see an encryption support prompt. Click OK if it appears. In the navigator, select the desired tables or views from the database. Click Load or Transform Data. Connecting to cloud sources, Excel on SharePoint or OneDrive via Web Connector. These methods uses the file's web URL. Firstly, get the file link. Then open your SharePoint site or OneDrive for business photo in the web browser. Navigate to Excel file. Open the file on the Excel desktop application, often via an open in desktop app or similar option. Once opened in Excel desktop, go to File, then go to Info. Click Copy Path. These copies the direct URL to the clipboard. Secondly, connect in Power BI desktop. Click Get Data, click Web. Ensure the basic option is selected in the Form Web dialog. Paste the copied URL into the URL box. Crucial steps. Delete the question mark web equals to 1 portion from the very end of the pasted URL. This is necessary for Power Query to navigate correctly. Click OK. If prompted for credentials, choose organizational account and signing with your Microsoft 365 or OneDrive SharePoint credentials. The navigator window will appear, showing the sheets and tables within the online Excel file. Select the one you need. Click Load or Transform Data. Note, when setting up scheduled refresh in the Power BI services for data source this way, use OAuth2 as the authentication method. Paying attention to these source-specific details like authentication types or URL formatting is essential for establishing successful connections. Understanding data types in Power BI. When Power BI loads data, it attempts to automatically detect the type of data in each column, that is text, number, or date, and assign an appropriate data type. While this automatic detection is helpful, verifying and sometimes manually changing data types is a critical step in data preparation. Why data types matter? Efficiency. Correct data types allow Power BI to store data more efficiently. For example, storing all numbers as integers uses less spaces than storing them as text. Numeric types are generally processed faster in calculation of relationships than text types. Accuracy. Using the right type prevents error in calculation. For instance, trying to perform mathematical operations on a column mistakenly identified as text will fail. Using decimal number for currency can sometimes lead to tiny rounding inaccuracies in complex calculation due to how floating point numbers are stored. Fixed decimal numbers. Avoid this. Functionality. Certain Power BI features and DAX functions require specific data types to work correctly. Time intelligence functions need proper date types, and some visualizations work best with specific types. Visualization. Power BI uses data types to offer appropriate summarization. For example, sum or average for numbers and count for text. And visualization choices. Common data types explained. Text, used for sequence characters. Letters, numbers, symbols. Example, customer name, product description, category name. Whole number, used for integers. Numbers without decimal points, Example, order quantity, employee ID, age. Power BI uses 64-bit integer types, allowing for very large numbers. Decimal number, the most common type for numbers that may have fractional values. Example, unit price, sales amount, temperature. Represents 64-bit floating point numbers, suitable for most numeric data. But be mindful of potential tiny rounding differences in extensive calculations. Fixed decimal numbers, also known as currency types in some contexts, stores numbers with a fixed precision, always 4 digits after the decimal points. Ideal for financial data where exact decimal representation is crucial to prevent rounding errors. Date and time stores both date and time information combined in single value. An example, date, store only date path, year, month, day. Example, time, stores only time path, hour, minute, second. Example, true or false. Boolean, stores only two values, true or false, used for logical flags or conditions. Example is active, as shipped. Binary, represent raw binary data, generally not used directly in the Power BI model, but might appear in Power Query when loading static file types. It needs conversion before loading. Any, a default type assigned when Power Query cannot determine the type. It's recommended to always explicitly set the data type rather than leaving it as any. Viewing and changing data types. You can view and change the assigned data type for a column in several places. Power Query Editor. Click the icon. Example, ABC 123 on the keyboard to the left of the column header, or use the data type drop down on the Home or Transform tab, or right-click the column header and choose Change Type. Power BI Editor after loading. In the Table View or Mode View, select the column and use the data type drop-down in the column tool ribbon. Selecting the appropriate data type is a foundational step that impacts how efficiently your model stores data and how accurately calculations are performed. Data loading, import and direct query. When connecting to data sources, Power BI Desktop offers two primary connectivity modes that determine how your report interact with the data source. Import and direct query. Import mode. This is the default and most common mode. Power BI Desktop connects to the data sources, reads the data, and imports a copy of that data into the Power BI file. When the report is published, this data copy is stored within the semantic model in the Power BI service. Report and visual query this internal caked copy of the data. Pros of the import mode. Performance. Report interactions, that is, filtering, slicing, and cross-highlighting, are typically very fast because queries run against the IA optimized in-memory VertiPark engine storing the imported data. Full functionality. Support the full range of Power Query transformations and DAX functions. Source independence. Once data is imported and refreshed, report performance isn't dependent on the availability or speed of the original source system. Cons of the import mode. Data preference. Data is only as current as the last refresh. Changes in the source system are not reflected until the next refresh cycle. Memory size limits. The entire dataset must fit within the memory limits of the Power BI desktop machine. During development and within the capacity limits of the Power BI service after publication, file sizes can become large. Refresh requires data refresh, manual or scheduled. To update the imported data, snapshots. Direct query mode. Power BI connects to the data source but does not import the data. It only stores metadata about the table structures. When the user interacts with a report, that is, applies filter, Power BI generate queries in the native language of the source, like SQL, and sends them directly to the source database to retrieve the necessary data in real time. Pros of direct query mode. Data freshness. Data is near real time as queries will eat the source system. Ideal when reports must reflect the absolute latest data. Large data sets. Suitable for data sets that are too large to report due to memory size or constraint. Supports the full range of Power Query transformation and DAX functions. Source independence. Once data is imported and refreshed, report performance isn't dependent on the availability or speed of the original source systems. Cons of direct query mode. Data freshness. Data is only as current as the last refresh. Changes in the source systems are not reflected until the next refresh cycle. Memory size limit. The entire dataset must fit within the memory limits of Power BI desktop machine during development and within the capacity limit of the Power BI services after publication. Files can become too large. Refresh. Requires data refresh, manual or scheduled to update the imported data. Snapshot. Data refresh. Data refresh is the process of updating the data within your Power BI semantic model if using import mode, or updating the visuals in your reports and dashboards if using direct query or live connection to reflect the latest information from the underlying data sources. Types of refresh. Data refresh. This applies primarily to input mode semantic models. It involves Power BI connecting to the original data sources, querying for new or changed data, and loading these updated data into the semantic model stored in the Power BI service. OneDrive refresh. If your Power BI file is connected to data sources stored on OneDrive or SharePoint Online, Power BI can automatically detect changes and update the semantic model, typically within an hour. Manual and scheduled refresh options are also available for these sources. I'll refresh. That is the dashboards. For dashboards in the Power BI service, the visual tiles are automatically refreshed periodically, about every hour, to show recent data. This applies even to direct query, live connection sources where a full data refresh isn't performed. Users can also manually refresh dashboard tiles. Visual refresh, that is reports. Reports visuals updates when the report page is loaded or interacted with. For direct query sources, visuals query the source data each time the render or are filtered. Automatic page. Refresh can be configured for direct query sources to update visuals at set intervals. How to refresh. Manual refresh. In Power BI Desktop, you can refresh the data in your local file by clicking the refresh button on the home ribbon. This updates the data within the desktop application only and does not update the published semantic model in your service. In Power BI service, you can trigger an immediate refresh of a published import mode semantic model by navigating to the workspace, finding the semantic model, and selecting the refresh now icon. This does not update the data used by reports and dashboards based on that model. Scheduled refresh. This is configured only in the Power BI service for import mode semantic models. It allows you to set a scheduled, for example, daily at 8 a.m., weekly, and Monday at 9 a.m. for Power BI to automatically perform a data refresh. Configuration involves setting the frequency, time zone, and specific times. Crucially, it involves and requires valid data source credentials to be stored in the service end if connecting to on-premises data sources. A configured and running data gateway. There are limits on the number of scheduled refreshes per day. 8 for Pro, 48 for Premium. Keeping data current is vital for reliable reporting. Understanding the difference between refreshing in desktop versus the service and properly configuring scheduled refresh, including credentials, gateways, are essential skills. We've now come to the end of all 2 basics for data analytics course, where we looked at connecting to data sources under the following units: importing data from Excel, databases, and cloud sources, understanding data types on Power BI, and data loading and refresh. In the next module, we are going to delve into data transformation and cleaning. Thank you. Now we're going to learn about to connect Power BI to data sources. The general process is consistent connecting to specific sources types involve unique details. So we're going to start with connecting to local Excel files or importing local Excel file into your Power BI interface. So going to Power BI. So in Power BI, you click on Get Data, which is here. A moment, please. Data. It's going to bring out a little options on the specificity of what you want: Excel workbook, XML, JSON, SQL Server database, Access Database, SharePoint folder, and others. For the sake of this lesson, we're going to be clicking on Excel workbook. Okay, so these are our options, but we're going to be searching for Power BI. Mind you, I have a particular tutorial focused file or data set I've arranged or downloaded for the sake of this lesson, which is Apocalypse Food Prep folder. So we're going to be clicking on it to start off. All right, so we're going to click on Apocalypse Food Data. Click on it. It's going to connect. It's going to show us the data. So it's connecting. It's connecting. Connect. All right. Now right here we have our navigator. If you have a lot of chats, you're going to click on the one that you actually want to use. So here you have your sheets that are in the folder. So I click on the sheet so I can load or preview the data before. Okay. So here you can actually select the exact sheet you're going to be needing. But for here, we're going to be just clicking on the sheets now we have, which is the only sheet we have anyway. So click on the sheet, sorry. So you can load or click on transform data. We're going to be clicking on transform data, which is going to take us to the Power Query. So it's going to take us to Power BI Power Query, which will allow us to transform our data. So this is not the focus of this, but let's check it, which is going to be like a brief class from it. So this is the Power Query editor. So it's basically to actually transform your data and get ready for your visualization. You can also do the same thing in the cloud if you want to. You can do it before now, but you can do it here. There are a lot of things you could do here, as you can see the plethora of options. Okay, so let's check it. There's something I want to transform quickly before we go and start building our visualizations. Okay, so we have the store persisted product, the price, and the dates I just purchased. So it just says data net. So we're gonna edit it to be more specific with date underscore purchased. More specific. Enter. So the apply step says remain cause. So every step that we take on this particular data, actually do anything or adjust on anything will show here. So you didn't want to do something like I didn't want to rename that column. So I'm just going to click on X and it's going to get rid of the date for please adjust. Edit it and take it back to its original state. So if you want it, so date underscore put. You can enter. So these are apocalypse food prep. This is the food we're buying for the apocalypse. We're getting through the apocalypse. Finally, this data set was gotten from a readily made data sets from one of the internet sources. So we're going to be focusing on the food that we're purchasing for the apocalypse. From that example. So under the products, we have bottled water, canned vegetables, dried beans, milk, and rice. Now, they all make sense except for the milk. So it wouldn't stay long, or it's not like a product that can actually stay longer through the apocalypse. So it could get spoiled. So wanted to get out. So we'll click OK. So couldn't tell you what you just did here. Here's the rows. So if you go down, you don't see milk in all of this. So afterwards, we're done. So we're going to be closing and apply. Excuse me. So we load the data to Power BI. So it's loading into Power BI, creating connection and model. Veltec. So for yellow rows loaded. It's loaded it into the Power BI desktop. On this left-hand side, it takes us to the report tab. But where we need to be is the dev tab. So to check our data that we just brought here, as you can see, the milk is not here. Under the data, where we can see the data and change it up a little bit, mix up effect, creating column or making new column. Like you can see, I bought different things at different types and dates. So many of the things we bought was from what's on Saturday and Tuesdays. So now I want you to know where exactly I get to my things more often, where it is cheapest that I could get most stuff. So looking at it from Costco seems to be cheaper. Where I bought the dry beans. So should I just be getting the things from Costco and everything else? Should I just get my dry beans from Costco and everything else from Walmart? So we're going to be going over to the report tab. So you can choose any of these aspects to work on your file. You could actually choose to maybe you want to work on a new data or you're just good to go. You could work to some the data about that. You can add a new visualization. You can add a new measure or measure the calculation section. So you can see that they actually broken down into data, queries, insert, calculation, sensitivity, share. Well, this is just a math system for Copilot, a feature of an upgraded system, Windows system. So we have Blish under share option. Okay, so we have the visualization area. It is a very important aspect of this dashboard because this is where a lot of creation of the visualization sits. So this is just a summarized view or introductory view to how you can import data from your Excel. Thank you. See you at the next video.
Thanks for watching. If you found this video helpful and you're passionate about learning, don't forget to hit that subscribe button. We share practical tips, deep dives, and step-by-step guides to help you grow your knowledge and skills. You can also visit our website through the link below to access engaging courses. So if you're ready to keep learning and stay ahead, subscribe now and turn on the bell so you never miss a new video. See you in the next one.
Welcome to the module 3 of Basics of Data Analytics using Power BI. In this module, we'll be looking at data transformation cleaning under the following units: Introduction to Power Query Editor, cleaning and formatting data, and handling missing and duplicate data. Introduction to Power Query Editor. Power Query Editor was a powerful data connection and data transformation engine built into Power BI desktop, as well as other Microsoft products like Excel. It provides a graphical user interface, GUI, called the Power Query Editor, which allows users to connect to a wide variety of data sources and then clean, reshape, and transform the data without writing code. It's the primary tool for the extract, transform, load ETL process within the Power BI. Accessing Power Query Editor. You can typically enter the Power Query Editor in Power BI desktop by clicking the Transform Data button, either in the home ribbon or selecting Data Sources in the Navigator window. Purposes of data query. Real-world data is often messy, incomplete, or inconsistently formatted. Power Query is designed to address these challenges by enabling users to remove error or inconsistency, handle missing values, remove duplicate entries, change data types, split or merge columns, filter rows and columns, pivot or unpivot data, add calculated columns based on existing data, combine data from multiple sources, tables. Cleaning and preparing data using Power Query is a crucial preliminary step before data modeling and visualization, often consuming a significant portion of the report development time. The goal is to refine raw data into high quality, structured, and formatable mode suitable for reliable analysis based on the principle garbage in, garbage out. Power Query Editor interface. The editor windows have several key components. 1. The ribbon. Located at the top, it contains tabs like Home, Transform, Add Column, and View. These tabs house buttons for applying various transformations to the outputs. Queries pane. Usually on the left, the pane lists all the data queries, which typically corresponds to tables you have loaded or created in your current Power BI file. You can select a query here to view and edit it. To preview and current view. The central area displays a preview of the data for the currently selected query. Important, this is often just a subset of data. Example, the first 1,000 rows. Crucially, ensure responsiveness, not necessarily the entire data sets. Query settings pane. Typically on the right, this pane shows the name of the query and, crucially, the applied steps. Every transformation you apply through the user interface, like removing a column, changing a type, filtering rows, is recorded as a distinct step in this list. Power Query remembers this sequence. When you refresh your data, these steps are reapplied automatically in order. You can click on any step to see the data preview at that stage. Modify step settings via the gear icon if available. Reorder steps or delete steps. This provides a powerful way to track, audit, and modify your data transformation process. The M language. Behind the user-friendly interface, Power Query uses a functional formula language called M. Every action you perform in the editor generates corresponding M code. While beginners can achieve a lot using just the GUI, the M code can be viewed and edited directly via the advanced editor found on the new View tab for more complex or custom transformations. Power Query visual interface, combined with the underlying M language and crucial applied steps features, provides a robust and repeatable system for preparing data for analysis. Common data cleaning techniques, step-by-step examples. Power Query Editor offers a wide range of tools accessible through the ribbon and right-click menus to clean and reshape your data. Here are some fundamental techniques. Removing columns. If a column is unnecessary for your analysis, removing it can simplify your model and improve performance. Method 1. Select the columns you want to remove by clicking their headers. Use Ctrl Shift for multiple. Right-click on one of the selected headers and choose Remove. Method 2. Select the column, go to Home tab on the ribbon, and click the Remove Columns button. Alternative. Keep columns. Instead of removing unwanted columns, it is often more efficient, especially with many columns, to select only the columns you want to keep. Go to the Home tab and click Choose Columns in the dialog box. On every column you don't need and click OK. Removing rows. You might need to know how to remove rows based on their position, content, or quality. By position, go to Home tab, click on Reduce Rows Group, click on Row, Remove Rows, Options, include Remove Top Rows, Remove Bottom Rows, Remove Alternate Rows, enter the number of rows to remove. Remove blank rows, Home tab, Reduce Rows, and click on Remove Rows, then click on Remove Blank Rows. This removes rows where all values are null or empty. Remove duplicates is covered below. Remove errors is covered below. Filtering. The most common way to remove rows based on their values is through filtering. Cover later, but accessible via column header dropdown. Changing data types. Ensuring columns have the correct data type is crucial. Method 1 is header column. Hit the data type icon located at the left of the column header. Select the desired type, for example, text, whole number, decimal number, from the drop-down list. Method 2, ribbon. Select this column, go to Home tab, click on Transform Group, click on Data Type drop-down, or go to Transform tab. Click on any column group, click on Data Type drop-down, choose the new type. Method 3, right-click the column header, select Change Type, and choose the new type from the top menu. Splitting columns by delimiter. Visible when a single column contains multiple pieces of information separated by a character, like a comma, space, or hyphen. Number 1, see the column you want to split. Number 2, access the tool. Home tab, hit on Transform Row, then click on Split Row, Column, Split Column, and click on By Delimiter. Click on Transform tab, click on Text Column, click on Split Column, then click on By Delimiter. Right-click on Edit Column Header, click on Split Column, click on By Delimiter. In the Split Column by Delimited dialog box. The Split Column by Delimited dialog box, select or enter the delimited character. Choose Split as the option. For example, leftmost delimiter or rightmost delimiter, or each occurrence of the delimiter. Choose Split into columns. Create new columns or rows. Create new rows for each split values. Click OK. Formatting data. Text example. Cleaning text often involves standardizing its appearance. Select the text column. Go to the Transform tab. Text column group. Format option. Choose an option. Lowercase, convert all text to lowercase. Uppercase, convert all text to uppercase. Capitalize each word, converts text to proper case. Trim removes white space character from the beginning and the end of the text, crucial for fixing invisible spaces that prevents matching. P removes non-printable control character from the text. Handling missing values, nulls and blanks. Missing values or missing data, often represented as null or blanks, can cause error or skew analysis. Replace value. This is versatile. Select the column, go to Transform tab, click on the Any Column group, then Replace Values. Replace null values, enter null in Value to find. Enter your desired replacement in Replace With. Click OK. To replace blank text, leave Value to find empty. Enter your replacement in replace with. Click OK. Fill down and up. Useful for propagating a value into subsequent down or preceding all null cells. Within the same column, select the column, right-click the enter, click on fill, click on down or up. Note, fill up requires blocks to be converted to null first. Remove rows with errors and notes. Select the column, click on Open tab, click on Reduce rows, click on Remove rows, click on Remove errors, or Remove blank rows. Use cautiously as it deletes the entire row. Replace errors. Sometimes operations like changing data type can never result in error values in cells. For example, try to convert NA to a number. Select the column, click on Transform tab, click on any column group, click on Replace Value drop-down, click on Replace Errors. Enter the value to replace errors with. Handling duplicate rows. Duplicate rows can inflate counts and skew aggregations. Select key columns. Select the columns whose combination of values should be unique. To remove rows that have duplicates based only on one column, for example, order ID, select just that column. To remove the rows where all the values across all columns are identical, select all columns, Ctrl A. Remove row based on a specific combination, for example, duplicate customer ID and order date. Select those specific columns. Remove duplicate. Click on Home tab, then click on Reduce rows, then click on Remove rows, then click on Remove duplicates. Or right-click on one of the selected column headers. Remove duplicates. Important considerations. Capital letter A is from Apple in small letter A. Use formats, lowercase or uppercase first if needed. Leading and trailing spaces or even characters can prevent duplicates from being detected. Use format train and format came first. Remove duplicates. Keep the first instance of a unique row and value based on the table current sort order. If order isn't guaranteed or you need to keep the last instance, you might need advanced techniques like sorting, adding an index, removing duplicates, and then removing the index, or using table buffer before removing duplicates. Data cleaning is often an iterative process. Use data profiling tools on the View Lab column. Column quality, column distribution, column profile. To understand your data characteristics and identify issues like errors, empathy values, empty values, and outliers before deciding on the appropriate cleaning steps. Remember that each cleaning action adds up its step to the applied steps pane, allow you to review and modify your process. We've come to the end of Module 3 of the Basics of Data Analysis course, where we looked at data transformation and cleaning under the following units: Introduction to Power Query Editor, cleaning and formatting data, and handling missing and duplicate data. In the next module would be delving into data model and DAX, data analysis expressions. Thank you. Alright, this video tutorial will be laying how to use Power Query in Power BI. Like we know where we use what's it called, this Excel file in the other or earlier video. We're still going to be using something similar to that, but in a more detailed manner. So we have our tabs open in Excel. Because all of these. So remember, we had Walmart, Costco, and Target. We have our product what is the price of dates. So for the apocalypse food prep, you get it right. So we have different food products that we're about to purchase for the apocalypse in years to come. We have rice, dried beans, bottled water, canned vegetables, milk, and we have other products purchased like rope, flashlights, water filter, duct tape, and whole bath. So this fourth color person actually added a pivot table to show the different sections, lookout score, target format, and the top total on the edge, and then the brand total. Now we're going to be using this a bit in learning about Power Query Editor. For more, especially we're going to be using the next I'm going to show you, which is the Apocalypse Food Prep Overview. They call it purchase for you. Now, what would you love people, individual or organization that makes use of Excel, you're going to be seeing this a whole lot. It's more or less like a surprise debut of the whole work, right? So this is just to show you the file we're working on. Now, going on to Power BI, so we can enter the Power Query Editor. So we're going to be importing data. We're going to import data from Excel. So we're going to be focusing on the Power Query Editor file. So it's connecting. Once again, it's going to bring you to the navigator, which is going to tell us where exactly we're about to go to. Remember, under the display options, it's going to show you the sheet on the edge. So we have about 3 sheets. Remember the other video I told you that you can have more than one here. Now you have the pivot table, the purchase overview, the purchase tracker, right? So we're going to be reviewing the edge. So you can see, you can see, right? So this is where we can choose what data to bring it or not bring it, right? So this is the video. So we're going to go to the pivot table and the purchase overview. Now we could just load it or just transform it. But because we're trying to work at the Power Query, we're going to click on transform data. Remember, Power Query is supposed to be for editing your files, making them well arranged or prepared to be fully exported into an API. So this is the Power Query Editor. So we have our queries here. You can click on those. You can click on them to go back forth of them, right? So up here we have the ribbons. They offer a lot of functionality. So we have things like use colors, remove colors, reduce rows, display colors. So these are the things we're likely to use when we're using Power Query. So there's another tab called Transform with a lot of functionality. So things like where you transposing, reverse columns and rows, and some other things that are here that will be useful, that will be useful in our work here. So there's another one that's called add column. It is self-explanatory. It has to do with adding additional color, deleting color, adding indexed color, or conditional colors. So there's also view, use, help. We're then looking at all of those now. So on the far right side, where our query settled, you have things like change the name, even able to get it clarified. So get your updates right here over our query side here. So we have our applied steps, which I told us earlier that is extremely important, right? Because anytime you make any changes, you transform the data, it appears here, right? So you can go back to look at it or delete that particular thing in the future if you want to, and go back to a previous version of whatever you just did. But when you upload it into Power BI, it does a beautiful things for you. Chooses the source and navigation, the promoter headers, and also change the data types. You can try to see the thing can change by click on this icon. It's going to bring up the path where we got this file from, right? If you want to change that, you can change it. But we need to change this in the future. We can come here to just change the file path. But when you're going to do that right now, so click and cancel. So we're going to go back to change that. So obviously, the headers aren't correct. So you can see we're working on pivot table, no the purchase overview. So the headers are clearly not correct. So it changed these column headers. So you actually changed it for us. Remember the applied steps. So if you look at, you're gonna see ABC 1, 2, 3, right? ABC 1, 2, 3. And here it's just ABC, right? So it's just saying that where you see ABC just means it's just gonna be text. The way you see ABC 1, 2, 3 is gonna be text and it's gonna be numeric. So let's go to just OB, which is what we're gonna be working the most. So we're gonna be looking at the pivot table a little bit, little references, and making some. So let's check how Power BI is taking this in. So it takes the apocalypse food prep view as the first column. And this was actually the header of what we were looking at before. Again, apocalypse food prep. So all the other columns are just column 1, 2, 3, 4, 5. And we have blank columns right here. No values, that you could see. So we're going to be cleaning up some of these. They can be more useful in more about Power BI tasks and visualization. This will be okay in Excel. But when putting into Power BI, it's actually not as acceptable because the reason why you're trying to put it into Power BI is because of visualization and not just to make it look good in Excel. We're going to be kind of trained it up. So we start from the end. I'm going to get it to the top rows. So we see that. So we're going to select him, remove rows, remove to rows. So we're going to select him sheet. So because I want to straight remove those. So the location product and this day, those are these. So this is now, the row is now location products and date home. But this is what we actually want to be our header, right? So we're going to click on this. So we're going to click on that, but we're going to click on transform. Click on transform. click on use first row as headers. So we have it as the header, location, product, and these dates as our headers, exactly how we want it. So to apply its steps, you can see it has removed top rows, promoted headers, and change types. So if you come to the remove top rows, see that it actually has all the column booklet food prep as the header, right? So if you come to the change types, everything has been affected. So the promotion of the headers, change your data type for us, giving us his best guess as to what the data type is. So changing type give us the his own best guess as to what the data type is. So in trying to see that this is decimal, we're trying to change the decimal. So we're gonna click here. That's the 1.2. So we're gonna click on fixed decimal number. We'll click on replace current. So you can see it's now better than what we had before, right? So since it's money, so it's all okay. So let's quickly go through others. I use them also. He was a second decimal since it's money, right? So fixed decimal number. Let me do that quickly. Replace current. Right. Replace current. And this is perfect. So for the purpose of what we're about to do, we do need a subtotal such as the cost code total or target total or the grand term. What we're going to do is to go here, look at the drop down. So we're going to filter and say remove empty. And it's going to take out all of those towers. So the next thing we're going to do is to get rid of the grand total column, right? So what we're going to do is to click on the top column off. So click on the top of the grand total. We're going to go back to home. We're going to say remove color. That's done. We've gotten rid of it entirely. Now this looks really good visually. Okay, this look all neat and well organized, yes. But then we still need to actually take care of these dates because when it comes to visualization, they might not be in the best format. So what we're going to do is to transpose them. Okay, so what we have with these dates is not really the best format, right? So we're going to be clicking on January 1st, holding your chip button and clicking on April 1st. Or you're clicking on the transform, right? So when we click on the transform, we're going to be clicking on the keyword columns. Now we have our table looking like what we had in our Excel file, right? That's recreating our original Excel file. So let's check it again. Let's check it again. So this is what we have. So this is what we had in the beginning, right? So this is really good and will be really good to be used for visualizations, right? So we want to actually clean this up a bit. So we're going to come to the data type. I click here and change it to 8. Okay, from the value. So we're going to be changing this to product. So fast. So for the location, we want to call it store. Right? So let's check out the pivot table, kind of back. So this will be very similar to when we first started, right? With it. Right. So we're done. We'll come back to purchase overview. Think you have good. Jeremy. So the next thing we're going to be doing is click closing and apply. All we've done, everything we worked on is going to be applied to the actual data and it's going to load into Power BI to create the visualization. So let's click that. Sorry. So now it's been pulled into the Power BI. It's loading. It's loading. Okay, it's downloaded. So we come over here. We have if you need to bring them back again into the Power Query transform, Power Query editor, right? So we're going to click on transform data.
Thanks for watching. If you found this video helpful and you're passionate about learning, don't forget to hit that subscribe button. We share practical tips, deep dives, and step-by-step guides to help you grow your knowledge and skills. You can also visit our website through the link below to access engaging courses. So if you're ready to keep learning and stay ahead, subscribe now and turn on the bell so you never miss a new video. See you in the next one.
Welcome to Module 4 of this basic data analytics course, where we'll be looking into data modeling and DAX, data analysis expressions, under the following units: creating relationships between tables, introduction to DAX, and writing basic DAX formulas. Creating relationships between tables. Relationships are the connections that links tables in your data model, typically based on one-on-one or more columns that exist in both tables, often referred to as key columns like product ID or customer ID. Automatic relationship detection. When you load data, Power BI desktop attempts to automatically detect and create relationships by looking for columns with matching lengths and data types in different tables. While helpful, this automatic detection isn't perfect and might create incorrect relationships or miss necessary ones. It is crucial to always review the automatically created relationships in the model view and make corrections as needed. Manual relationship creation. You have two main ways to create relationships manually: model, view, drag, and drop. This is often the quickest method. In the model view, simply click and drag the key column from one table and drop it directly onto the corresponding key column in the related table. Power BI will create the relationships and attempts to determine its properties automatically. Secondly, manage relationship dialogue. This method provides more explicit control. Go to the Modeling tab on the ribbon. Click on Manage Relationships. In the dialog blocks, click New. In the Create Relationship window, select the first table and its key column for the drop-downs. Select the second table and its corresponding key columns. Power BI will suggest relationship properties, cardinality, cross-filter direction, which you can review and modify. Click OK to create relationships. Key relationship concepts, cardinality. These define the numerical nature of the relationship between two tables. How many rows in one table can relate to rows in the other? One to many and many to one. This is the most common and generally preferred type. It means one row on the one side, for example, one customer in a customer table, can relate to many rows on the many side. For example, multiple orders in an ordered table. But each row on the many side relates to only one row on the one side. A key column on the one side must contain unique values. Power BI usually detects this automatically, but will error if the uniqueness condition isn't met. 1 to 1. Both related colors contains unique values. Less common often indicates potential for merging tables. Many to many allows many rows in one table to relate to many rows in the other. Requires careful consideration specific model design patterns, often involving a bridge table. Cross-filter direction. This setting controls the direction in which filters flow across the relationship. Single. Filters propagate only in one direction, typically from the one side to the many side in a one relationship. This is the default and usually recommended setting. Both. Filters propagate in both directions. Bidirectional. Allows filtering the one side table by selection made on the many side. Use this setting cautiously as it can sometimes lead to ambiguity in filters path or negative impact profiles. Active and inactive relationships. Power BI typically allows only one active filter. Path between two tables at a time. If multiple paths exist, for example, relating a sale table with date table, variables, or the date and ship date, only one relationship can be active. Additional relationship can be created but must be set to inactive. Inactive relationship don't propagate filters by default but can be specifically activated within DAX measures using the user relationship function. Correctly defining relationships, particularly their cardinality and cross-filter direction, is fundamental for ensuring your calculations of report filters behave as expected. You don't rely solely on automatic detection. Always review and validate relationships in the model view. Introduction to DAX, data analysis extraction. What is DAX? DAX stands for data analysis as preference. It is the native formula and query language and it is used across Microsoft Business Intelligence tools, including Power BI, Power Pivot, in Excel, and analysis services. DAX is not a programming language in the traditional sense, but rather a collection of functions, operator, and constants that can be combined to build formulas. expressions to calculate and return one or more values. Purpose of DAX and Power BI. While Power BI drag and drop interface allows for basic aggregation like summing a cell column without writing formulas, DAX unlocks the ability to perform much more sophisticated analysis. Its primary purpose is to enhance the data model by adding custom calculations that goes beyond the raw data imported from source system. DAX enables you to create new information from the data already present in your model. Examples include calculating profit margins, year-over-year growth, comparison against targets, or creating complex conditional logic. Relationship to Excel formulas. For users familiar with Microsoft Excel, DAX syntax and many of its functions like sum, average, if, today, left will seem familiar. This familiarity can make learning basic DAX easier. Key differences from Excel formulas. Despite similarities, DAX operates fundamentally differently from Excel formulas. Columnar operations. DAX functions typically operate in and on entire tables or columns, not on individual cells or cell ranges like Excel. Context. DAX calculations are evaluated within a specific context. The two main types are row context, performing a calculation for each row of tables used in calculated columns, and filter context, the set of filters applied to the data model by visuals, slices, or other DAX formula with effect measure calculations. Understanding context is crucial for writing correct DAX formula. Relational data focus. DAX is designed to work with relational data models and include functions for navigating relationships between tables, like related and related table. Table functions. DAX includes functions that return the entire tables as result, which can then be used as input for other functions, enabling powerful dynamics calculation. Time negligence. DAX can provide a rich set of built-in time negligence functions for performing common database calculations like year-to-date, YTD, previous year comparison, and moving averages. DAX is the engine for advanced analysis within Power BI. While basic reports can be built without it, mastering DAX is essential for creating fully insightful and customized business intelligence solutions. DAX fundamentals. DAX formulas are written in the formula bar in Power BI desktop, which appears when you create a new measure or calculated column. Understanding the basic building blocks is the key to writing effective formulas. Core syntax element. Measure and column name. Every calculation starts with the name you assigned to it. For example, total sales, full product category. Equal signs. This operator separates the name from the formula expression and indicates the start of the calculation. Functions. These are predefined calculations. For example, sum, average, related, if, calculated. Functions names are followed by parentheses. These enclose the arguments required by a function. Most functions require at least one argument. Tables and column references. DAX formulas operate on tables and columns within your data model. Table name. Often referenced directly. For example, cells. If a table name contains spaces or special characters, it needs to be enclosed in a single quote. For example, product category. Column names. always enclosed in square brackets. Fully qualified names. The standard way to reference a column is using the format table name, column name, for example, sales. This involves ambiguity, avoids ambiguity, and makes formula easier to read. Through the table name can sometimes be omitted if the context is clear. User, operator, used for calculations and comparisons. Examples are arithmetics, plus, minus, subtraction, comparison equals to, not equals to, test and concatenation. And logic, and or not. Argument, values passed into functions. Multiple arguments within a function are separated by commas. Argument can be column reference. Constant, like numbers or text. Strings in double quotes or other DAX expressions. Example, breakdown, measure, total sales, equal sign, sum function, parentheses and closing arguments, sales, argument, fully qualified, column reference. Writing basic DAX formulas. DAX allows you to create two main types of calculations: measures and calculated columns. Understanding their differences is crucial. Creating measures. Measures are formulas designed for aggregation and typically are used in the values area of visualization. Their results are dynamic and changed based on the filter applied in the report. Filter context. They don't add data to your table or consume significant memory in the same way columns do. How to create measures. In the fields pane, right-click the table where you want the measure to reside. Usually the table containing the main data being aggregated. Select new measures. Alternatively, select the table and use the new measures button on the modeling or home tab. Basic aggregation functions. Sum adds all numbers in a column. Syntax. Example, total revenue equals sum sales. Average, calculate arithmetic means of numbers in a column. Syntax. Count the number of cells in a column that contains numbers. Syntax. Counter, count the number of non-blank cells in a column, text or numbers. Syntax. Count rows, count the total number of rows in a specific table. Syntax. Distinct count, counts the total number of unique distinct values in a column. Syntax. Min max, find the maximum or minimum value in a column. Syntax. Creating calculated columns. Calculated columns add a new column to an existing table in your model. The formula is elevated independently for each row of the table. Row context. During data refresh, and the results are stored as part of the table, consuming memory and disk space. How to create. In the field pane, right-click the table where you want to have the column. Select new column. Alternatively, select the table in the data or model view. Go to the table, choose ribbon tab, and click new column. Common use in cases and examples. Concatenating text. Combining text from different columns. Row level math. Performing calculations using values from the same row. Conditional logic categorization. Assigning values based on conditions using if. Extracting date parts. Getting year, month, or day from a date column. Using related values. Pulling a value from a related table on the one side of the relationship using related. We've now come to the end of the Module 4 of this basic data analytics course, and we looked into data modeling and DAX, data analysis expressions, under the following units: creating relationships between tables, introduction to DAX, and writing basic DAX formulas. In the next module, we'll be looking at creating data visualization. Thank you. All right, welcome back. So we're going to be looking at DAX in BI tutorial. So DAX stands for Data Analysis Expression, and it's basically a library of functions and operators that help you build formulas. You can use it in creating measures and calculated colors within Power BI, which could give you a lot of insight into your data, right? And it's not complicated. So moving on. All right, so let's take a look at our tables and data before we get started. So we'll have two tables: the Apocalypse Sales, the Apocalypse Store, the Apocalypse Store table, and the Apocalypse Store. So under the Apocalypse Sales table, let's go to Data, Table View. Okay, so under the table view, under the Apocalypse Sales, we have the customer, the product ID, order ID, unit code, and the date purchased. For the Apocalypse Store, we have product ID, product name, price, and production cost. Now, they are going together through the product ID, right? Through the product ID. What brings them together is the product ID. So we're going to be using these new measures and new colors to create new measures. We're moving, please. So we're going to be using, like I said, new measures and new columns to create our DAX functions. So let's go over to the report tab, report view, right? So let's drop down on there. Stop computers, my habit balance field, right? Let's drop both down. Everything is clear. We're gonna go with my Apocalypse Sales, right? Click on new measures. It's gonna open up this right here. This is where we can create our functions. So it automatically gives us blank measure, or we can change it definitely. We're gonna change it to count of sales. Count of sales. So now we can start writing our DAX function, right? It's gonna show up right here. Once we click count of sales, we're good. Once we click enter, or we'll click on this commit, right? It shows up right here in the right corner, count sales. So now we can create our DAX. Click here, you can say count, after counting, it brings up options, which is called IntelliSense in other Microsoft functions. Which allows you to look at other options very quickly. So we're going to take on count. So it's prompting us to put in a column name. Go to select one, but we'll type it out so we can type future. What's a future prediction? So we want to use order ID. So we'll click on order ID. So I just started already predicting what we need. Click on it. We're going to close the parenthesis. Okay, sorry. Click. Okay. Enter, or you can come here if you click enter. So, right. So we can view this by clicking this box next to the count of sales. Okay. So we'll prefer to check it in the table. So where is it? Table. Now you can see that there are 74 tables. But what we're seeing is buying what? Who is buying more of our products? Who is the client we have? So we're going to choose customer. So we're going to put customer on top of sales. Or easily Like I said, just say move up. So you're gonna pull it out. Let's just be like this. So uncontrolled structure of actually two orders, right? But having a large number of orders doesn't mean you're spending more on like plus. Check that later on. So, so how many products? What are the products that are really selling more than the others? What are our big parts, right? So we have 10 different items, but we don't know which one is selling the best. So whether the product's name, we have our product here. So we're gonna go back to upper sales, right click, select new measures. So for this, we're gonna call it the sum of parts. So products. Okay, so we're gonna start off by sorry, in it. It's the text kicks. Okay, so we're gonna go sum. So you don't bring it out again. Oops. So you might think this is like Excel, right? So this is actually similar. Remember, these are Microsoft tools and their functionalities will definitely be similar, right? So if you're used to Microsoft products, you have some similar, should I call it similarities? So moving on. So or some open brackets. Now we're gonna choose units sold, right? We want to come up with the units sold to see how much or how many are actually sold selling. Close the parentheses and click the checkbox to just commit. Oh, so after we click enter, it's going to appear here some on product sold. So we're going to click the checkbox inside it. It's going to come up here because we have like about 2,000 products sold, right? So moving on. So the person that buys most of the product is this small to survival life. Index motion can be really simple. You can write them so simply that it can stand or be used for good insight that you can use for your visualization as you move on. So, want to take a look at difference between sum, which is an aggregate function, and something like sumx, which is an iterator function. Because if you add x to some of the iterator function, you can create them or link them into an iterator function, right? So you can have sum and sum x or average and average x. Added x to any of the aggregate function, link that into an iterator function. Now let's check how it works and the differences between both. So going back to data, going to the apocalypse, or we have the price and we have the production cost. So we want to look at how much profit we get from each of these, as well as we can take a look at the units sold and how much money we actually make it, right? So we're gonna come back over here. We're gonna go to Apocalypse Store, right click and create new measure. So it's gonna automatically bring up measure. We're gonna name it profit. We're gonna come over here. Let our sum of the price includes parentheses, includes tracts, the sum of the production costs. Production costs. By just like subtracting your cost price from your selling price, right? So you can measure out your profits. Okay. We're going to calculate it. It's when you use a multiply function, right? So you're going to close it here. So it's going to be like a double. So closing the parentheses here also. So that would be good. Now we can use our multiply afterwards. Multiply by sum, then sum. Sum of the units. Sorry. Multiply by sum of the unit sold. Sorry. Unit sold. So after closing the parentheses here, so we have to check right here. So have the profit. So we're gonna create different table, right? So let's click on the profit. So we're gonna be clicking on the profit. Let's bring it here. Oh, that's not what we want. So click it as table. Right. Oh wait, you can table. So it's right over here. Now we have a profit, but we want to know which customer is spending the most money at our store. So we're gonna call over here and click on customer. So here it is, right? Here we see that Uncle Joe Pet Shop is spending more money at the store, right? So, but we're gonna put up customer shop, move up. Now, what would you actually show is actually the differences between, or rather difference between sum and sum X. So what we're going to do is go back to the profit. So we're going to copy this the entire frame. Copy it. I'm going to go back to this table U. So create a measure, okay? So right here is the table view. So we go up to home. So we're going to create a new column. So we're going to call it profit underscore column. Profit underscore column. So we're going to paste in the exact same thing we copied here. And hit enter. Okay, sorry. So I'm doing this. Go here. All right. So we have this. Click. So we now see that each row is the exact same thing. So what it's doing is going through the price. It added all of it up and calculated at the bottom. It's added the production costs and added up at the bottom. And then it's been over to look at how many units it sold. And then it's performing this calculation up here and give us the total units for every row. But then that's what we want to show. What we wanted to show is the profit for each row. So here is the price for the price for the row, and then how many units were sold, and then it will calculate that and give us the actual profit just for that goal, right? But we can't just do it without using this sum. So we need to use what is called the sum X. So let's add another column. Let's go back to loan. So we click on new column. Now we're going to say profit underscore color, right? From the core sum X. Make it English sum X. And we're going to use sum X if tab. So we're going to leave the table where we put it into or collect cells, which is the table we're trying to look at here, right? So we're going to say comma. We're going to use an expression that says it returns the sum of an expression evaluated for each row in the table. Before we are just using sum, it's like you're looking at all these combined. Now it's taking it row by row, right? Now what we're going to do is basically include the same thing as we did before. We're going to copy and going to paste that. It's not going to correct. Okay, moment please. It's okay. It's not going to be correct. Okay, you get rid of some sums, but let's go ahead. So after the comma, we paste. It's going to be correct. Okay, so we're going to get rid of this sum and all. Just go and be like, okay, we'll also get rid of this sum. Obviously. All right, so we're going to also get rid of this sum. This. Oh, it was this get rid of this Q. So have it as open fills. This sum. Please. Right. Get rid of this sum also. Parenthesis. Okay. Offer results. Yeah, so okay, let's go over again to be sure did the right thing. Okay. Okay, this isn't supposed to be here. Okay, so I think we're good. Let's look through it one more time. Okay, look at those. Some X, right? So I think we're good. So we're just gonna click enter. Oh, now this looks a lot better. Now, what this is showing us is that at row level. Now, this nylon robe has $51,000 and almost $52,000. The waterproof mattress is just $15,000. And we can go down, look at each item and see how much it actually made us versus the profit column. So that is the difference between sum and sum X, right? Okay, so let's go back to the appropriate cells. Now over here we have the date for text. In the DAX function, we have some ways we can interact with dates. So let's take a look at them fast. So we can go here and click on new color. You're going to link that color. We're going to say it's day. Now there's different ones. We have a lot of them. You have a couple of days, BS, couple days, day, network days, next day, President's Day, today, weekday. Okay, all pretty self-explanatory, right? Let's click on weekday. Now it says it's going to return a number from 1 to 7, identifying the day of the week of a day. So let's use it very quickly. 8 purchased. Okay, carbon. We're just clicking it. And the car. It's going to give us a 3 different options, 1, 2, and 3. Now, if you read this, you're going to free out to read more of this, right? You're going to say Sunday is equals to 1, through Saturday we can say equals to 7. So I'm going to click on 2. Those are parentheses. I just change this to day of week for the correct. So let's check. So Saturdays are equals to 6x. Mondays are equals to 1. Now this allows us to see which day of the week people are buying the most products on, or which day of the week is somebody submitting their orders. So let's go over to the reports. Report views. Let's try to get, okay, let's here. Let's look up here. So I'm going to show you the difference between what we just did and what we already have. So we now it's purchased, right? Let's click on it. Oh, sorry. That was what I intended to do. So click it out. So we have date purchased. Okay. A moment, please. Okay. So we're gonna make it into self-name with a moment. So let's make it into a bar graph. Okay, where is it? A moment, please. Okay, we're making it to a bar graph. We're gonna be looking at if the unit sold. So right here. So we have this for 2022. So we have 2022, but with no one like here, so we're gonna get it right here. So I will cut it right. Oh, all right. So we have a quarter. So we remove that cube. So right here we can see January, February, March. So you can tell that January has the most sales, or the most units sold in the month of January. So, but if we get rid of the month, we get on to April. The specific day the ice products were sold, right? So moving on. So, so we do have some information, but we do not know what day of the week it exactly is. It could change from month to month, and it's really hard to tell exactly what if there's any pattern there at all. So that's where we just create what we just created comes in handy. So let's create this exact same thing, but instead we're going to use day a week. So we want to select day of the week or day of week. Here's more. Day or week. Or I'll type separately. Day or week. And unit sold. So let's drag it here. And then spread it here. A moment, please. Okay, I'll try to drag it. Oh, the days of the week should be in the x-axis, right? So the day of the week should be on the x-axis, right? So there that's, and it's pretty easy if there's a pattern here, right? They're really not at least for those same data that we have, at least, right? So we move on to this on the visuals. Go on to the table labels, turning on quickly. See, it's not easy. See, so we can take. Well, it's not really suited, but that Monday as the highest. So the middle of the week as more sales, right? More sales. So our Wednesday and Thursday are blue below the rest. And the beginning and the end of the week to be the highest. Because again, not a huge pattern, but it's much easier to see if there's a pattern from week to week or for one day of the week. Now that we use this weekday forecast. So this can be really, really useful. So let's go back to rotator. Okay, so on the data, now we're going to look at our last DAX function for this video. So let's go up here and create a new column. I will go to declare something called the if statement. Now, if you've ever used Excel with certain, you must have edited this and you can do the exact same thing here in Power BI. And so we're going to name it one, let's send this one order size or order underscore size, right? So what we're going to say is I have, so then click on this. So we need to perform a logical test. And then we want to say if it's true, what our value, if it's false, what is our value? So what we're going to be looking at is unit sold. So if unit sold, right? Unit sold is greater than, okay, that's it. Greater than 25. If it is larger than that, if it is true, it's larger than 25. Sorry, it is a big order. And if it's not, if it's not, so if it's a true, big order, and if it's not, it's small order. Sorry, not small order. Right? You can close that. So the parenthesis. Please, okay. So we say if it's a big order or it's small order. So you can see right here, it's a big order or a small order. So that will be all we have for you in introduction to using DAX and Power BI.
Thanks for watching. If you found this video helpful and you're passionate about learning, don't forget to hit that subscribe button. We share practical tips, deep dives, and step-by-step guides to help you grow your knowledge and skills. You can also visit our website through the link below to access engaging courses. So if you're ready to keep learning and stay ahead, subscribe now and turn on the bell so you never miss a new video. See you in the next one.
Welcome to the Module 5 of those basics of data analytic course using Power BI, where we'd be looking at creating data visualizations under the following units: understanding Power BI visuals, tables, charts, maps, KPIs, building interactive dashboards and customizing visuals and filters. Overview of Power BI visuals. Visualizations or visuals are graphical representations of data such as charts, graphs, and maps. Their purpose in the Power BI is to present data and insight in a way that it is easy to understand, allowing users to quickly identify patterns, trends, and outliers that might be hidden in raw numbers. Effective visuals help tell a story with data. Common Power BI visual types and their uses. Bar and columns chart. Standard visual for comparing discrete values across different categories. Bar charts displays categories horizontally, while column charts display them vertically. Excellent for showing rankings and comparing magnitude. Clustered version compare multiple series within categories. Stacked version show parts of a whole within categories. Line chart. Ideal for showing trends and changes in continuous data over time or another sequence, like stages in a process. They emphasize the overall shape and progression of a data series. Error chart. Similar to line charts, but with the area below the line filled in, emphasizing the volume or magnitude of change over time. Stacked area charts shows how the composition of a total changes over time. Pie and donut chart, used to show proportion of parts relative to a whole. Percentage breakdown. Pie charts are circular. Donut charts are similar, but have a hole in the center. Best used with few categories. Can become difficult to read with many slices. Tables display data in a standard grid format with rows and columns. Excellent for showing details and detailed numerical data, precise values, or when multiple related values for items need to be displayed together. Supports conditional formatting. Matrix. Similar to table, but allows for grouping data row and or columns with options for stepped layout and drill down or drill up functionality, much like a pivot table in Excel. Maps, used to visualize geographical data. Power BI offers various map types. Basic map and bubble map shows data point as circles on a map, often sized by value. Field map. Choropleth uses color intensity to represent values across defined regions, countries, states, zip codes. Shape map, similar to a field map but uses custom shapes. ArcGIS map, integrated maps from Esri offering rich mapping capabilities. Cards display a single significant number prominently, ideal for key metrics or totals. Single card numbers. Single number card. Show one value, e.g. total sales. Multi-row cards. Show multiple related single data point, one per row. KPI, key performance indicator. A significant visual designed to show progress towards a defined goal or target. Typically displays a base value, a target value, the status, for example, ahead or behind, and a trend. Answers. How far am I on my goal? Slices. These are interactive filtering control placed on the report canvas. Allow users to easily filter their other visuals. They don't display data per se, but enable exploration. Other visuals. Power BI includes many other scatter charts showing relationships between two numeric variables, waterfall charts showing cumulative effect of positive and negative changes, funnel charts visualizing stages in the process, tree maps, hierarchical data as nested rectangles, gauge charts, and so on. Sources of visuals. Power BI Desktop include a core set of built-in visuals in the visualization pane. You can also import additional custom visuals developed by Microsoft or third parties from integrated marketplace, app source, or load them from files. For advanced users, Power BI also allows creating custom visuals using developer tools. Choosing the most effective visuals depend on the type of data you have and the message or insight you want to convey. Building an interactive dashboard report. In Power BI, you primarily build reports within Power BI Desktop or the Power BI service. Dashboards are features exclusive to the Power BI service, created by pinning visuals from one or more reports. Building reports in Power BI Desktop. Report canvas works within the report view. The default view when you open Power BI Desktop, which features a blank canvas area. Reports can consist of multiple pages, accessible via tabs at the bottom. Adding visuals. Select the desired visual types icon from the visualization pane. An empty template for that visual will appear on the canvas. Alternatively, drag the data from the fields pane directly onto the canvas. Power BI will attempt to choose an appropriate default visuals based on the data type. Populating visuals with data. With a visual selected on the canvas, drags field from the field pane into the appropriate field wells, like access, legend, values, tips, etc. Located under the visual icon in the visualization pane. The available wells depends on the selected visual types. Arranging the layout. Move. Click and drag any visuals to reposition it on the canvas. The size. Click on visuals to select it, then click and drag the handles on its borders to change its size. Align visuals to create a clean and organized layout. Interactivity. By default, visuals on the same report page are interactive. Clicking on a data point on one visual, for example, in a bar chart, will typically cross-filter or cross-highlight related data in other visuals on the page, allowing for dynamic exploration. Slices add another layers of user-controlled filtering. See section 5.5. Creating dashboards in Power BI service. Prerequisite. You need one or more reports published to the Power BI service. Pinning visuals. Open the report in the Power BI service over a visual you want to include on your dashboard. Each pin visuals icon looks like a thumb tag. In the Pin to Dashboard dialog, choose New Dashboard. and give it a name, or select an existing dashboard from the dropdown. You might be asked whether to use the report's theme or dashboard's theme. Click Pin. Pinning live pages. You can also pin an entire report page to a dashboard. This creates a live tile where you can interact with the visuals directly on the dashboard. Arranging dashboard tiles. Navigate to the dashboard in Power BI service. You can click and drag the pin tiles to arrange them and rearrange them and drag their corners or edges to resize them. Dashboard purposes. Dashboard provide a high-level at-a-glance view of key metrics, often consolidating visuals from multiple reports onto a single screen for monitoring purposes. Clicking a tile usually navigates the user back to the source report page for more detailed exploration. A report building involves selecting appropriate visuals, configuring them with data, and arranging them logically. Dashboards in the service provides a complementary layer for summarizing and monitoring the most critical insights from those reports. Customizing visuals. Power BI offers extensive options for customizing the appearance of your visuals to improve clarity, match branding, or highlight specific data points. Assessing formatting options. Select the visuals you want to customize on the report canvas. In the visualization pane, click the Format Visual icon, which looks like a paintbrush. The Format pane will display various cards sections containing customization options specific to the selected visual types. The visual type selected. General setting, often under General card. Title. Edit the visuals title, text, font, style, size, color, background color, and alignment. Effects. Add a background color or image. Adjust transparency. Add borders or apply shadows. Header icons. Customize the icon that appears when hovering over the visual header. Tooltips. Configure the information shown when hovering over data points. Alt text. Provide text description for accessibility. Visual specific setting. Examples. X-axis and Y-axis. Turn axis on or off. Changes the scale type, linear or log. Set range, min or max. But formats, font color display unit. Customize axis tiles. Legend. Turn on or off. Change position, top, bottom, left, right. Customize the tile and text formatting. Data colors. Change the default color used for all data series, or assign specific colors to individual categories or series. This is where you apply corporate branding colors. Conditional formatting for colors. Base data colors on rules or value gradients. For example, color bars based on sales amount. Accessed via the FX button next to color options. Data labels. All labels on or off display values directly on the visual. Customize their position, font color, display unit, and background. Some visuals allow adding secondary metrics. Detail labels. Grid lines. Control the visibility, style, color, and thickness of horizontal and vertical grid lines. Column bars. Adjust and space and apply borders. Lines. Change line style, solid dashed, dotted, stroked with shape markers. Map controls. Zoom buttons, map style, road, area. Resetting. If you make changes you don't like, most formatting cards include a reset to default link at the bottom to revert that specific section's setting. The Formats pane provides granular control, allowing you to fine-tune the look and feel of each visual element. Experimenting with these options is the best way to learn how to create clear, effective, and aesthetically pleasing visualizations. Applying report themes. Themes provide a quick and consistent way to apply formatting choices, like colors, fonts, and visual styles, across your entire PowerPoint, Power BI report. This helps to ensure a professional look and can be used to align report with corporate branding guidelines. Applying built-in themes. Power BI Desktop come with several pre-designed themes. Navigate to the View tab at the ribbon. On the theme section, click the drop-down arrow below the main theme button. A gallery of built-in themes will appear. Hover over a theme to preview it on your report canvas. Click on the desired theme to apply. All visuals in your report will instantly update to reflect the theme's default colors, fonts, and other settings. The list includes accessible themes designed for users with visual impairment. Customizing and importing themes. If the built-in themes don't meet your exact needs, customize current theme. Select a built-in theme that is close and click Themes. Drop down, Customize current theme. A dialog box appears, allowing you to modify core settings like colors, theme, sentiment, divergent, text, font, family, size, color for different element, visual default, page background, and filter plane appearance. You can save those customization as a new theme file. Import theme. You can apply themes defined in an external JSON JavaScript object notation files. These files allow for highly detailed customization of nearly every visual property. You can create your own JSON file or download them from sources like Power BI Community. Theme Gallery. Accessible from the theme dropdown. Import, click the themes dropdown, browse for themes, and select your saved JSON file. Using themes is far more efficient than formatting each visual individually, ensuring consistency and saving significant development time. We've come to the end of Module 5 of this basic of data analytics course using Power BI, where we looked at the creating data visualizations under the following tenet: understanding Power BI visuals, tables, charts, maps, KPIs, building interactive data dashboard, and customizing visuals and filters. In the next module would be delving into publishing and sharing reports. Thank you.
All right, so we're going to be dealing with visualization in Power BI Desktop in this particular section. So, first of all, this is our interface. If you usually updated Power BI Desktop as at 2025 May. So, we're going to be opening our interface. Home. So we're going to be going in. So, I would like you to go through the data, right? You had the data, like I taught us earlier, Excel workbook. So we have the Apocalypse Food Prep. Like I mentioned, Apocalypse Food Prep is a file that was brought into a line source just to use for the sake of this tutorial. So Apocalypse Food Prep, open. So it's still loading. So we're going to see the navigator here. It has a display of the Apocalypse Food Prep file and how many sheets are on that particular Excel file. So we click on the sheet. If there's multiple sheets, you're going to see everything here. So you click on the specific one you'd like to use. So click on the sheets, bring up the load. Okay. So we're previewing what we have. A moment, please. So in preview, what we have is everything we have. So we're going to select a sheet 1. That's the only sheet available. So we'll click on sheet 1 to upload or transform data. We're going to be transforming data, which is going to take us to the Power Query Editor. Now, this is the Power Query Editor. Now, Power Query Editor does similar things to what you could have done in Excel. So you could either do it before you import to Power BI and do it in your Excel. But if not, you can still edit some things on your Power Query Editor. We're going to be talking more Power Query Editor later on. So what are the things you can do? For example, the date. You could edit your dates here. Date underscore or text. For text. Right? Let me make this into a capital. They put text. So we click enter. So you notice your applied steps will show here, and then we click enter, show that you renamed a column. So for editing columns, rows, and all of that. So if you make any other change, it's going to appear under the applied steps. Now you can also revert your changes. So by clicking on this cancel red button, so you click on cancel, you have your date back. But we still want it to be with ist or easy understanding of our date. The ist. Call ist. All right. Okay, later. So now we're not done. Now we come over to products. Now under products, we have bottled water, canned vegetables, dried beans, milk, and rice. Of all of this, which one could stay preserved all through the period of apocalypse? Now, the milk might not stay through the period of the apocalypse. So we're removing the milk. So excluding the milk. Okay. Once again, full chart robot. It appears under the applied steps. Right? So when we are done, I think we're good to go. We'll click on those and apply. So it's going to start loading. Okay. It's going to load to bring the data to the Power BI desktop interface. So give visual. So after this, you see that we're already good to go, right? So we have on visualization, and here we're going to be working with a lot of these, like a lot, right? So you will see that we have our sheet here loaded. We have it and state here. We're going to drop them. And so we have that it shows us all our columns, the date, what case, the price, the product, the store. We want to discover where we spend the least amount of money, in which store we spend the least amount of money. So that is what we're going to be getting our products. Spend less to get more our products, right? So least amount of money, find the exact same product. So there's a secondly, there should everybody know my product at the exact same place, or there are certain products that are cheaper at other stores, right? Maybe we're trying to buy ahead of an apocalypse. So we're going to start with the first one. So we're going to just see the store and the price. So at a quick glance, you're going to see that we're spending the least amount of money. Sorry, I'm trying to make it more visual. Spend the least amount of money in Costco, right? So to Target, which 219 and Walmart to 225. But want to visualize it better to make you see it in a better way, right? So we converse visualization would be okay. So the one that would make sense to make it okay is a start column chart. It's going to show Walmart, Target, and Costco. Let's see, we're showing this in color, right? Or showing this in color. So we're gonna add a legend. So we're gonna add store down here, down to the legend. So let's make this larger while we're working on it. So we can see we're spending the most amount of money at Wallet in when it started, and Costco is the lowest. So right here, we know that Costco is the place to go for buying up food, right? But that is it going to be the same way for Amazon products? Because this is just like our general, right? It's generally the cheapest, but not the cheapest for, or maybe it is for some and not for others. So let's take a look about this. Let's put this over in the corner. Okay. I think that's cool. Okay. That will be cool. So let's start a new one. Sorry. We're going to be selecting the products. Products. Oh, sorry. So in case you have something like this, just click on this. Just hit remove. We're going to be starting another one, which is going to be selecting of the products, the price, and the store. See that? So we're going to be visualizing it. So which should we use? Stack. Let's not use that column. Let's use the cluster column. Right? Okay, it's more easy to navigate or understand, right? Sorry, I'm just trying to make it not too bold. Okay, you have this, so let's move up. Let's make this larger. We can see everything we need is here. We can see each product is right here. Rice, stragglers, butter, pan, vegetables. We can see the sum of price we're paying in each store. So we're paying a lot more rice and walnut. So we're paying the least at Target because Costco is so high for rice. So the paybacks for Costco, we're paying less for dried beans and bottled water. Oh, we're spending a lot less money at Costco, but if you want to take a little bit more money, go to Target for our price. So if you want to get this dashboard, only keeping these two things, right? You can close and open your fuels good here. We're going to size them, right? The size them looking like this. Model says. So this is looking good. So we want to change the title of both of these, right? So to change that, we're going to go over here in our visualization and format your report page, format in visualization. So we're going to be, sorry, let me make it broader. Right, so to rename it come font, right? So you format, come to general. In your title, so you can name it anything you really want. Right? Name it anything you want. So let's come here. So this you can say let's store for products. Right? Okay, so while I'm still here, you're going to do visuals. I just filled in some visuals. We haven't really added any Legos, so when we take on their Legos, so you're gonna read the value over overwrite, right? Like you can see here. So over. So we're gonna come to broadcast. Displaying units on the lobby. So it's in the thin down, so it's the actual lobbies. You can do it setting all the here. So we're gonna cut to I page. Okay, the type page. Just name it total I store. So visuals like we did the other time. Devil labels. All right. Okay, so we have it here. So we're able to export data from our Excel folder, and we're able to actually bring it here to the Power BI database, adding it to the Power BI database, editing it to actually need up to what to do, right? And giving it a visualization. And the visualization necessary. Costco is actually the cheapest place to buy products ahead of apocalypse. Apart from rice and canned vegetable, I'm going to save a few dollars, which is able to targets. Thank you.
Thanks for watching. If you found this video helpful and you're passionate about learning, don't forget to hit that subscribe button. We share practical tips, deep dives, and step-by-step guides to help you grow your knowledge and skills. You can also visit our website through the link below to access engaging courses. So if you're ready to keep learning and stay ahead, subscribe now and turn on the bell so you never miss a new video. See you in the next one.
Welcome to Module 6 of this basic data analytics course, where we'll be looking at publishing and sharing reports under the following unit. Overview of Power BI service, sharing and collaborating on reports, and automating data refresh and scheduled updates. Overview of Power BI service. The Power BI service also known as Power BI Online, is a cloud-based platform provided by Microsoft that allows users to publish, share, and collaborate on reports and dashboards. While Power BI Desktop is used for building and designing reports, Power BI Service is where you publish, view, share, and manage them online. Key features: publishing reports. Easily upload reports from Power BI Desktop to the service. Dashboards. Combine visuals from multiple reports into a single interactive dashboard. Workspaces. Organize your report and dashboard into collaborative environment. Package and distribute reports and dashboard to large audiences. Natural language queries. Ask questions about your data using everyday language. Data alerts. Set automatic notification based on data threshold. Benefits. Accessibility. Access your report anywhere from a web browser or mobile app. Collaboration. Share insights with your team securely and easily. Integration. Connect with other Microsoft services like Teams, Excel, SharePoint, etc. Sharing and collaborating on reports. Once a report is published to the Power BI service, you have multiple options for sharing and collaborating. Sharing options. Direct share. You can send a direct link to specific individuals via emails. You can control permissions, view, reshare, or build on the data. Workspace. Collaborative spaces where teams can co-author and manage reports together. Different roles: admin, member, contributor, viewer. Publish to web. Publicly share reports on website or blogs. Not recommended for sensitive data. Collaboration tools. Comment. User can leave comments directly on visuals in the report. Integration with Microsoft Teams. Embed reports into Teams channels. Discuss insights without leaving Teams. Subscription. Set up emails subscription to send report snapshots at scheduled intervals. Best practices for sharing. Set clear permission. Always check who can view or edit your reports. Use role level security, RLS. Ensure that users only see the data they are supposed to. Keep data secure. Be cautious when using public to web as it makes the report public. Automating data refresh and scheduled updates. Keeping your data fresh is crucial for accurate and timely insight. Power BI service allows you to automate data refresh so that your report and dashboards always reflect the latest data. Steps to set up scheduled refreshes. Publish the report to Power BI service. Configure data sources credentials. Make sure Power BI can access the data. Set refresh frequency. Choose how often you want to refresh. Daily, weekly, multiple times a day. Premium capacity allows more frequent refreshes, up to 48 times per day. Monitor refresh history. View past refreshes. Check for errors and troubleshoot if needed. Gateway configuration for on-premises data. Personal gateway. Best for individual use, simple installation. Enterprise gateway. Suitable for large teams and shared data sources. Advantages of automating data refresh. Consistency. Always work with the latest data without manual uploads. Efficiency. Save time and reduce errors. Real-time insight. Enable near real-time reporting for business and critical decisions. Conclusion. By mastering the Power BI service, you move from being just a report creator to data communicator. Sharing reports effectively, setting up collaboration, and automating data refreshes empower you and your organization to make faster, better, and more informed decisions. We've come to the end of the basics of data analytics using Power BI, where we looked at publishing and sharing reports under the following unit: overview of Power BI service, sharing and collaborating on reports, and automating data refresh, and scheduled updates. As you continue to develop your data analytics skills, consider exploring advanced topics such as data storytelling, predictive analytics, and machine learning. With Power BI, you can unlock the full potential of your data and drive business growth through data-driven decision making. Thank you.
Thanks for watching. If you found this video helpful and you're passionate about learning, don't forget to hit that subscribe button. We share practical tips, deep dives, and step-by-step guides to help you grow your knowledge and skills. You can also visit our website through the link below to access engaging courses. So if you're ready to keep learning and stay ahead, subscribe now and turn on the bell so you never miss a new video. See you in the next one.